All right, my friends, let's see how you did here. For this one, I would consider the plus 2n to be the inconvenient part. The 5 doesn't bug me at all. I can just factor the 5 out front. So for me, that 5 is not a big deal. I don't like the plus 2n. I wish it wasn't there. So let's see what would happen if I compared to the sum as n goes from 1 to infinity of 5 over the square root of n cubed, which simplifies to be 5 times the sum as n goes from 1 to infinity of 1 over n to the 3 halves. And so let's think about, this part. So your p-value would be 1.5. And so it's on the right side of 1 to converge. And so which is a convergent p-series. Okay. So we know it's a convergent p-series. Now let's compare the value of the terms. So if we're comparing it to something that converges, that we're comparing it to something that goes to 0 fast enough to add up to something finite, where would we need these terms to be located for our logic to work? That's right, we would need them to be underneath to say that they also converge. So let's see if that's true. Furthermore, so 5 over the square root of n cubed plus 2n. I'm actually going to compare it to the pre-simplified version of the terms, so it's a little bit more clear, I think. So how would it compare if you're adding 2n? And notice n would only be positive numbers since it only goes from 1 to infinity. We won't have to worry about n being something like -1 or -5. So you're basically adding 2 times a positive number down there. And so if you're adding a positive number, and so it would make your denominator bigger. So I hope it makes sense that if you're dividing by a bigger number, you'd get a smaller result. And if that does not make sense, then seriously imagine, take a pizza divided by, more friends, you get less, Anyway, so we have the position that we want, and so we can just make our conclusion. So therefore, the sum as n goes from 1 to infinity of 5 over the square root of n cubed plus 2n also converges by the comparison test. There we go. All right, my friends, hopefully that makes sense. Okay, let's have you practice part B here. The sum as n goes from 1 to infinity of 1 over the square root of n squared minus 9.